block is coming along. Still got a couple more little spots to hit, but it's getting pretty clean. Wanted to give a shout out to Humble Mechanic. I was watching one of his videos. He was using green scratch pad and the WD-40. He was working on a VR6 engine, Volkswagen guy. Used to have an R32, awesome cars. I'm assuming that's an aluminum block, and if that was a steel block and this is aluminum block and green scratch pad no good, then it's a little late now. One thing I did want to mention, that obviously after all that work to get the head studs off, I now have head studs on again. And my original block, since given the mileage, I was going to have it decked and inspected and all that. Given that this is a newer block and looks to be in really nice shape, I took it to a local machine shop, which is getting harder and harder to find. All these old guys are retiring and closing their businesses. But anyway, I was able to get the bores measured, and they were all within spec, so I didn't really see the need to ship this thing off to Lindsay Racing. I talked to Mike about the head studs, and for my application, reusing these head studs, he said it shouldn't be a problem. Originally I was going to use ARP head studs, but we're just going to go ahead and use it as is. So I got mostly the top done. I'll start working on the crank girdle next and hopefully get this crank in. So I got the crank back from the machine shop. It was actually a different machine shop because the other one didn't want to work on this. And another old guy that seemed to know what he's talking about, but I don't know that much about it. So he thought this was already drilled, because it's drilled up here, but I don't know. Talking to Mike at Lindsay Racing, they said they cross-drill the rod journals. My understanding would have been a hole through here, just like the main journal, but I am not a machinist. He did clean this one up, polished it. He said he magnafluxed it, and I asked him to measure the rod journals so I could at least have numbers when I play with my micrometer set to see if I got the same thing. And when I asked him if he had measured them, he said, yep, it was all good. Followed up with all good, meaning they're all within spec. Yep. So I'm assuming he looked up what a 944 spec crank rod journal clearances are. I can only assume. I'm going to remeasure them and double check that, and then obviously measure my rod clearances as well. Flywheel looks brand new. I should have done a before and after picture. So this is a two-stage flywheel, so up here and up here. And what the guy told me is they measure the distance before they machine it, then they machine this down, and then machine this down, so you have the same distance. So that looks brand new, so I can install it into the new pressure plate and have that ready to go for installation when we get that part. So we got the crank, we got the block, we got flywheel. Still need to pull cam tower apart and clean that up. Actually, I'm going to paint this. That's the only thing I'm going to paint. I haven't decided on the color yet, but hopefully give it a little bit of bling. I don't want to paint the engine block. I'm not going to spend that much time to get it that clean. It's an aluminum block. I don't think it's really necessary. You just end up with paint that gets a mess later, years down the road. So once I get the rest of this cleaned up, actually clean up the outside with some just degreaser, hose and water. I'll switch it out, get it on the stand, and get it blow dry air dry all the ports. I also grabbed a set of their thread chasers, basically. So M6, 8, 10, 12, 12. So 12 1.25 and 12 1.50 for the thread type, and a 12 1.75. So I'm going to clean out all the threads on all the holes for these size. Make sure they're all clean before we put everything back together. I'll put a link on Summit Racing. They were, I don't remember, 10, 15 bucks, something like that. Just to make sure everything's nice and clean. Well, I hope this is good, because it is about, I can get all I can get off of this thing. A couple of the spots where you still can see some dirt. I don't feel it feels smooth, unlike before I could feel when there was dirty spots. Everything feels pretty good, so I don't know how much more scrubbing I can do. It doesn't seem like much more is coming off. So we started on the bottom. Also cleaned up the crank girdle. A couple spots still need a little bit of attention. There's a little bit old gasket maker or something. A little bit there and a little bit on there, but otherwise looking pretty good. Clean enough to torque it down, put the bearings in, and check the tolerances. So I'm going to briefly walk through that process. If you don't have one, I'd highly recommend getting workshop manual. I was able to download one from online for about $25. Print out the pages you need, start putting them in a binder. So the pages that we have in question, I got the crankshaft back from machine shop, and I had to buy myself there's two ways to do this. One, using a micrometer set and bore gauge, and the other way is to use plastic gauge, which the manual actually shows how to do that. I haven't seen whether actually they show to do the bore gauge method. So I got this, and my bore gauge is still in the house. Set off of Amazon. It's Fowler. As I was looking up videos on how to make or use these things, I saw quite a few like this, so I think it's good enough. It took me a little bit of help trying to figure this out. Watch some videos. A friend of mine helped. So there's different sizes. So this is 0 to 1. So what confused me at first was how to actually get the numbers left of the decimal. So in this one, it's zeroed out when it's closed. On this one, it's 1 to 2, and you use your 1-inch block. I keep forgetting the name of these things. And you zero it out on the block, so 0 will be when the calipers hit this block, and then so on and so forth. The bigger the caliper, the bigger the block, up to your 5 to 6 inch block, or your measurement. So all of my measurements, and there's quite a bit of math and some converting you need to do. So if you can see the connecting rod, this will focus, connecting rod bearing journal, 51.971 to 51.99 millimeters. So of course I bought a set of micrometers in inches, so you've got to convert that, which is you have to divide by 25.4. So my rod bearing number 1 and my 2 inches, and then you add up all your, I'm not going to give a class on how to read the micrometer, there's plenty of stuff out there, but I will stress the importance of being able to go to 4 decimal places, and I'll show that in a minute. So my first measurement, 0.25, 0.21 plus 0.001, which is 1/10,000ths, giving me 2.046 times 25.4, and I get 51.9709. So even if I round that up, I'm right at my bottom tolerance. So I measured this one again because this was my first time using it, and I got something slightly different. I got 2.025 again, and then instead of 0.2021, I got 0.022, or sorry, I still got 2.1, and then instead of 1/10,000ths, I got 5/10,000ths, equals 2.0467, or sorry, 465 times 25.4 gives me 51.9811, which, as you can see, is right in the middle of my tolerance. So the difference of 4/10,000ths makes a difference between it being within tolerance at 0.9709 and right in the middle of the tolerance. So be able to learn to use this thing and practice with it takes a little bit of skill. You can always throw a vernier caliper on there as well, kind of get practice using. One of these you can pick up relatively cheap, 10 or 20 bucks from Harbor Freight. I wouldn't skimp on your micrometers because you need to get to 4/10,000ths pretty accurately, but you can put this on something and measure it and then practice with your micrometer and work at getting better at it. So I went through all the rod journals, and 0.9735, it's at the lower end of the scale, but it's still within tolerance. 0.9963 is actually too big, and if I went back and remeasured this, I'm guessing it would be closer to the smaller side, but I figured 200,000 miles on this crankshaft, there's no way it's too big. So that's just me and an error. But you can see the difference, 0471 versus 0462, and what it comes out to on the end. And then the last one, 51.97, again, it's right in there. So now that I have the the actual journal width, you want to set the micrometer to that width, and then you take your bore gauge and stick it in here, and then you take your bore gauge and compare it to your rods with the bearings in there, and make sure you have the proper clearance. So the clearance I have, connecting rod, I know this is hard to read, so I'm reading it to you. Connecting rod bearing, radial play, and then the crankshaft end play. So the end play will be the back and forth in between the crankshaft and the bearings, but the connecting rod bearing radial play should be the space in between the rod and then the rod journal with the bearing. So that is 0.034 to 0.092 millimeters. So you got to divide that by 25.4, because my micrometer is going to read in inches, and I get 0.0013 to 0.0036 inches, or that would be 1.3 10,000ths and 3.6 10,000ths. And then you go and do the same thing with your rod, your main journals. So I measured all of those as well. So my clearance I'm looking for the main journals was 69.971 to 69.990. So I did the same thing, measured those all out. The first one I got 69.98. You can see that's right in the middle. 9745. That's in there. 972 and 977. So those were all good within tolerance. So now I need to get the bore gauge, put the bearings in the rods. You need to torque it down. You need to have some way to hold it. You can buy a rod holder, which I was tempted to do. It was $100. I ended up buying $4 vinyl vice clamps that have a magnet in there. $4 for these parts plus $8 in shipping, 12 bucks, or you can buy some on Amazon for just 12 bucks and free shipping. Either way, it's going to cost you about 12 bucks. Some of them have different. I wanted one that was relatively smooth. It's got some marks on there, but they're flat. Other ones have cutouts that are kind of designed for doing round objects. You putting a round pipe or something into a flat jaws on your vise, it doesn't work so well, so they make them angled. So try to find something that are flat. Even these, they're really squishy. I don't know if these rods come torqued down, but it was I barely actually got the bolts loose. And the nice thing about this design, these are Molnar rods, is these bolts are part of it's all one piece. So when I put these in there won't be bolts sticking out. Some are fixed studs that stick out, and then when you put the rod with the piston into the cylinder, you got to make sure you put something on the stud so it doesn't ding the crankshaft when you put it in. So you can use a piece of fuel hose. You can buy special rubber tubes to put on there, but since these come all the way out and the whole cap will come off, there'll be nothing there. So that's kind of a nice design. I'm not even sure. Let me look at how Porsche did theirs. Yeah, as you can see how Porsche has theirs, it's the stud actually comes out of the rod. So when you put this down into your cylinder, you got to make sure you don't ding your crank with your stud. So you got to put some kind of cap on there instead of rubber hose or fuel line or something like that. Stick them out so they're nice and long, and then put them down in there. So the Molnar rods I got are actually a better design than what Porsche has for ease of installation anyway. The rods are supposedly a pretty weak point on the engine. That was the one thing I didn't have to replace. But talking to Mike at Lindsay Racing, he said the rods were actually one of the weak spots. So I had to replace pistons, I had to replace the head, ended up having to replace the block. Basically my crank is original, and that's about it. So everything else is getting upgraded. These are my new main bearings, so I need to get out the rod bearings and start putting those in the rods and measuring them. So we'll do that here in a sec. So I set my micrometer up to the dimension of the first journal that I measured. Now this is where buying the rod holder comes in handy, or if you have two vices, because you kind of need a vise to hold your micrometer while you try and get this in there and set it to 0. Now I've already done this. It's just a matter of getting it back in and holding it. But basically you set this to 0, and I don't know if I'm going to be able to do this with one hand. So I'm looking for 0. It's hard to hold and film this, so that's basically it. So I've got this set to read 0, so I'm looking for between 0.13 and 0013 and 0036. So this gauge, the small ticks are 0.0005. So basically up here between the 1 tick is going to be your 0.001, the first big tick, and then 0.0015, 0.00. So I'm looking for it to be between 1.3, so 1 and then before that first line, and then between 3.6. So I've got the bearing in the rod, and I torqued it down to the first torque specs. This is what you get from Molnar, so it gives you different bolt types. So I've got 7/16, and I measured it. I got 1.6 under the head. So that's, I'm using the degrees method. I'm not going to measure the stretch. 30 foot-pounds plus 60 degrees. So I just did it down to the 30 foot-pounds because I don't think the 60 degrees will make a difference on this measurement. That maybe is about as close as I can get it. The legs on the tripod are just sort of in the way. So I'm about at 1, 2, 3. 1, 2, 2.5 to 3. Which is right where I want to be. So, and then you would adjust your micrometer to your next measurement from your from the rod bearing. Set up if it, it's going to be very slightly different. Set the 0. Put the second rod in there, and then check it. Make sure the clearance is where you want to be, and then you go back and I need to do that, I'll put the crank girdle and the main bearings on the block and do the same thing to measure those tolerances. And all you're really doing is making sure that your bearings are within tolerance. And the other method is the plastic gauge method, where you put everything together. You put your plastic gauge on your journal, you crimp everything down to torque, and then you take it apart and measure the plastic gauge to make sure it's in there. Either way, you got to put everything together and torque it down and then take it apart to check it. I sort of wanted to learn how to use the micrometer set and do it this way, so I'm at least giving it a shot. Try to do this. So far so good. It's coming out where it needs to be. And then once you measure your rods, you want to set them aside and leave the bearing on there. And then I guess you don't really have to label them yet because they're within tolerance, but you can just lay them out so you have which ones you've done. So I just thought of a way to make this a little bit easier. You got to switch your rod out anyway and set your new measurement on the micrometer. So while you have the rod out, set your micrometer in there, zero your bore gauge, and then switch your rod. So now you have a pair of hands. You can check this, set it to 0, a little bit easier. That's looking pretty good. Take this out. Put the rod in. This takes a little bit of persuasion. It's off. Guessing anybody who's ever actually done this or is actually watching this has probably seen some other videos of how to put these in, but I do have some cleaning wipes on the way. I'm still waiting for them to show up, but all this stuff will get wiped down before final assembly. Just going to put the tang and slide it in, make sure it's flush on both sides. Your caps have numbers on them, so you can't really mess it up. If you take them all apart at the same time, 0299, the other one is 030, and it lines up with the number up on the rod. But I'm just going to do them one at a time, so there's no way I can mess it up. You want to get the cap down all the way. You don't want the bolt to pull it in. You want to have it fully seated, and then put the bolts in. Nice and smooth. Again, we're at 1, 2.5. Between 2.5 and 3. I have up to 3.6, so it's looking good. Now I want to point something out because I'm going to come back to this later. When I put these in, this was perfectly smooth and clean. Those aren't scratches per se. There's a coating on here. Now I had my first main bearings that were really scratched up that you could actually feel nicks, and I sent them back. But I talked to actually a different company that had main bearings, and these are the rod bearings I had, but they're the same type, they're same glyco. You can see those scratches, but you can't feel them at all. This coating apparently wears off immediately after putting it in. So even using the barometer, the bore gauge, not the barometer, it puts those scratches in there, but those aren't really scratches. I don't feel anything at all. It's just taking off that coating, so that's okay. But if you can feel any nicks at all, that's bad. You want to not accept the bearings and send them back, which I had to do with the main bearing.